Hi, geometry classes. This is the lesson on the unit on circles, lesson 5, and today we're going to talk about tangents. So let's first define what a tangent line is. A tangent line intersects a circle at exactly one point, and that point is called the point of tangency. All right, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. Okay, so a tangent line intersects a circle at exactly one place, and we know if a line is tangent in a circle if it's perpendicular to the radius at that point of tangency. So I'm going to highlight in yellow line AB. That's a tangent line. It's intersecting that circle at exactly one place. Now we know that it's exactly one place because look at this radius here. This radius is perpendicular at that point of tangency. All right, so A is called the point of tangency because we can have a line that looks like it's only intersecting at one place, but it's not. So we know for sure if it's perpendicular to the radius at that point. So in example 1, we want to determine if AB is tangent to the circle at P. All right, so here's AB. It looks like it's tangent, but the only way I would know for sure is if this was perpendicular right here. If the radius AP was perpendicular to that tangent line AB. So basically, we're going to test out Pythagorean Theorem, because if it's perpendicular, then the Pythagorean Theorem would work. So I'm going to do 14 squared plus 11 squared. Oh, and I got a small little problem here. I know this little piece is 5, but I really need to know the whole hypotenuse, or what looks to be the hypotenuse. We don't know for sure because we don't know it's a right triangle. That's what we're testing out. All right, so I need to know this other little part here. So I'm going to highlight this in red so you can see that in red is really just a radius. And if the other radius was 11, that makes this radius 11. So then this whole segment is 16. So 14 squared plus 11 squared equals 16 squared. That's what I'm testing out. 14 squared is 196. 11 squared is 121. 16 squared is 256. And nope, it is not tangent. The Pythagorean theorem doesn't work. So AB is not tangent. As I said, it could look like it's intersecting that circle in one spot, but we only know for sure if it's perpendicular to the radius. So in 2, 3 form, we just want to test out if they're tangent. All right, so again, this was 11, this was 11. So that makes this whole, actually, I'm sorry. On these, I'm telling you they're tangent. All right, so all of these lines are tangent. This is tangent, this is tangent, this is tangent right here. Okay, so if they're tangent, then that means that is perpendicular to the radius at that point. So I'm going to use the Pythagorean theorem to find x in each situation. All right, but sometimes I might have to be a little creative in figuring out certain lines. Like LK is really L11 plus 7, which is 18. Now I could do the Pythagorean theorem. X squared plus 11 squared equals 18 squared. All right, so I know that these lines are all tangent, therefore they're perpendicular. So these are all right angles on all of them. So x squared plus 121 equals 324. I subtract 121 and I get 203. So basically x is the square root of 203. All right. And unless they tell me to round it off, I'm really just going to leave my answer just like that. All right. 3 is going to get a little bit trickier. Again, this was a radius, so that makes this also 10. So this whole hypotenuse is actually x plus 10, just like I did before, but I don't have numbers. So look what's going to happen. I'm going to have 10 squared plus 24 squared equals x plus 10 squared. This one's going to be tricky. 10 squared is 100. 24 squared is 576. X plus 10 squared means x plus 10 plus x plus 10. So you have to FOIL this. X times x is x squared. x times 10 is 10x. 10 times x is 10x. And 10 times 10 is 100. You always get 4 terms. Those 2 middle terms can be combined together. All right. And I have a quadratic here. When you have a quadratic, I need everything to go to one side. So I'm going to subtract 676. All right, so then I'll have everything on one side, x squared plus 20x minus 576, because I'm subtracting 576, but I'm combining that with the 100 that's there. Now I have to factor this. The only way to solve this is to factor. All right, now this one's a tough one to factor because I'm looking for the factors of 576. What you can do to find factors of a number, you can use your calculator, all right? And if you go to, pretend you're entering it in as an equation, so I go to y1, and if I do 576 divided by x, so the number you're trying to find the factor of, you take that and you divide it by x, and then the factors will be listed there. So I'm looking for factors that multiply to 576, but that will give me a positive 20 as a middle term. And if you look down, you go to the table and you look, you're going to have positive 36 and negative 16. Then you set each factor equal to 0. All that does is change the sign. So basically my answer is 16. I'm not going to use the negative 36 because I'm talking about the length of a line, and the length of the line can never be negative. Okay? All right, number 4, we'll practice one more of these. The radius was 11. That makes this radius 11. That makes this whole side over here 22. All right, so I'm going to have x squared plus 22 squared equals 25 squared. This is just a regular one that's pretty simple. If I subtract 22 squared, you can do that in the calculator all at once. You can do 25 squared minus 22 squared, and you get 141 instead of finding each one separately and then subtracting them. And then I'm just going to leave my answer just like this. Unless they told me to round it off, that's my answer and I'm done. Okay? One more thing I have to tell you about tangent lines. If 2 segments from the same external point are tangent to a circle, then they are congruent. So basically, if AB is a tangent line and CB is a tangent line, and they meet at an external point out here, then those 2 tangent lines are congruent to each other. All right? I've seen this nicknamed the hat theorem. So picture, when you were little and you wore those birthday party hats. Okay? These are just 2 tangent lines. They're congruent to each other. All right? So a nickname is hat theorem. But if I have 2 tangents that meet at an external point, then they will be congruent to each other. So if you have a polygon is circumscribed around a circle, then all sides are tangent. So basically, I'm going to color them, highlight them. These 2 sides are tangent, all right? So they're equal. These 2 sides are tangent, they're equal. And these 2 sides are tangent, those are equal. All right, so DB is congruent to BE, EC is congruent to FC, and AF is congruent to AD. So using that, we're going to just try a few problems on the back, not too many, so you can see how that works. So number 5, these are just tangent lines. They're meeting at an external point, therefore they are congruent to each other. All you're going to do is set them equal to each other and solve. Okay, so 8x minus 19 equals 5x plus 23. I'm going to subtract the 5x because I'm solving for x here. Add 19. And divide by 3. Okay? Same thing is sort of going on the next one, except they ultimately want us to find, what do they want us to find? SV. Okay, so at the end, I'm going to find SV. I can't do that if I don't know what ST is. Look at this. This is just a right triangle, because remember, a tangent and a radius are perpendicular to each other. So that's a right triangle, that's a right angle. Therefore, I can use Pythagorean Theorem to find SV, but I can't do that right now because I don't know what ST is. But these are 2 tangent lines. They're equal to each other. So let's set up an equation to solve for x. And once I know what x is, I can go back and substitute it in and find st, and then I can use the Pythagorean theorem. So this problem's a little bit longer. The two tangents I set equal to each other. So I'm just going to subtract 4x, add 41. Now I know what x is. So let's find st. St is 10 times 8 minus 41. That's 39. And now that I know this is 39, now I'm going to do the Pythagorean theorem. I'll call this y, just not to get confused. So 17 squared plus 39 squared equals y squared. All right? And then if I do that in my calculator, I get y equals 42.5. Okay, so you can see that we can do a whole bunch of things just by knowing that rule. 7, I want to find the perimeter of triangle DEF, so that's this whole triangle right here. So remember that these guys are equal to each other, so this is 11 right there. And then remember that these are equal to each other. So if that side's 16, this side's 16. And then the last ones, remember that these are equal to each other. So if that's 9.5, this is 9.5. So basically it's just that hat theorem 3 different times. So the perimeter is going to be 11 plus 16 plus 16 plus 9.5 plus 9.5 plus 11. My perimeter is 73. Okay, and same idea on number 8, except I'm going to have to sort of subtract to find things. This side's 23, that makes this side also 23. And if the whole side was 37.5, I'm going to do 37.5 minus 23, and that will give me 14.5, which makes this 14.5. All right, this I already knew was 27.1, so that makes this 27.1. And the whole side, just get green, this whole side was 52.5, so if I do 52.5 minus 27 was that 27.1? All right, oops, sorry. All right, that's going to give me 25.4. So that makes this side right here 25.4. And again, I want the perimeter, so I have to add up everything. Now the sides that you have the whole side, you can just add those up. So let me highlight everything in, or circle everything. Here, maybe I'll do this in this color. So I need this side, the whole side. I don't have to add the 2 parts, I already know them. The 2 parts, and then the whole side. So if I add all those together, all right, I get 180 is my perimeter. All right, so we'll practice those 2 things tomorrow. That a tangent is hits a circle at 1, it intersects a circle at 1 point only, it's perpendicular to the radius. And the second thing was that hat theorem. Those 2 tangents that meet at an external point are congruent.